Okay, now we'll see how to do problems based on temperature stresses. The question is, a steel rail is 12.6 meter long. So what is L? L is equal to 12.6 meter, which is equal to 12.6 into 10 raised to 3 millimeter. It is laid at a temperature of 24 degrees Celsius. The maximum temperature expected is 44 degrees Celsius. So we can write the change in temperature T is equal to 44 minus 24, which is equal to 20 degrees Celsius. Estimate the minimum gap between two rails to be left so that the temperature stresses do not develop. Temperature stresses do not develop means it is allowed to expand freely. Okay, so what is the minimum gap? If it is allowed to expand freely, we can write delta L is equal to no temperature stress alpha into T into L. Okay, so we can find out this one. Alpha is equal to, for steel it is given 12 into 10 raised to minus 6, and T is 20 degrees Celsius, into length is 12.6 into 10 raised to 3 millimeter. Okay, so you will get the change in temperature, change in length, that is change in length is the minimum gap we have to provide to allow full expansion, which is equal to 3.024 millimeter. That is, if the rail is allowed to expand fully, then we will have to provide a gap of 3.024 millimeter as the expansion joint, so that there will not be any development of temperature stress. So this is the first part of the question. Now the second part is calculate the thermal stresses developed in the rails if no expansion joint is provided. No expansion joint provided means it is not allowed, it is fully prevented in expanding. So we can write the temperature stress or thermal stress is equal to, we have designated it as sigma. Temperature stress sigma is equal to, you know the equation, is equal to E into alpha into T. V is the Young's modulus of elasticity. It is given as Young's modulus of elasticity capital E is equal to 2 into 10 raised to 5 mega Newton per meter square, which is equal to 2 into 10 raised to 5 Newton per millimeter square. So we can write here 2 into 10 raised to 5, alpha is 12 into 10 raised to minus 6 into T is 20 degrees Celsius. So you will get the answer as P is equal to 48 Newton per millimeter square. So this is A part of second question. Now what is the next part? Next part, B is equal to, what is B? Question is, if a 2 mm gap is provided for expansion. So let us draw the figure here. You have the rail. Now if the rail is allowed to expand freely, you have obtained the value. It will expand to a distance equal to delta L, which is equal to alpha into T into L, and you have got that value as 3.024 millimeter. Okay, if it is allowed to expand freely, it will expand to a distance of delta L. Now it is given that a 2 mm gap is provided, that is, there is a gap which is equal to 2 mm, and if this is allowed to expand, or the rail is allowed to expand for this much distance only, that is capital delta. We have taken this earlier. capital delta is equal to capital delta is equal to what is the value? It is given delta is equal to 2 millimeter. Okay, if it is allowed to expand freely, it will expand to a distance is equal to alpha into t into L, and that is equal to 3.024. Now a gap of 2 mm is provided so that the rail can expand up to 2 millimeter. So this much distance is prevented, or this is not allowed to expand, and the joint is provided this distance only, so this distance is prevented. So we can write this is delta L. This is delta L. So this much distance is prevented in expanding. So a force is applied P, and this P will prevent the expansion equal to delta L. So we can write the equation PL by AE. PL by AE is equal to alpha into T into L minus delta. Okay, is equal to alpha into T into L minus delta. So we have to find out what is the thermal stress, that is P by A. You have to find out. You know alpha into T into L is equal to 3.024 minus delta is 2. This is equal to 1.024. So we can find out what is P by A, that is the thermal stress. So we can write the thermal stress or temperature stress. Thermal stress sigma, which is equal to P by A, is equal to, you have got the equation, alpha into T into L minus delta into E by L. So you have got this value as 1.024 into 2 into 10 raised to 5 divided by L is equal to 12.6 into 10 raised to 3 millimeter. So you will get the equation as P is equal to, we will get the P by A, temperature stress is equal to 16.254 Newton per millimeter square. Okay. Now the last part of the question is, if the stress developed is 20 meganewton per meter square, what is the gap left between the rails? So the temperature stress developed sigma is given as 20 meganewton per meter square, which is equal to 20 Newton per millimeter square. Okay, so you have the equation PL by AE. PL by AE is equal to alpha into T into L minus delta. Okay, you have to find out what is delta. Delta is the unknown. Now you have the equation P by A is equal to 20. Length is equal to 12.6 into 10 raised to 3. Okay, E is equal to 2 into 10 raised to 5. Alpha is equal to 12 into 10 raised to minus 6. T is equal to 20. L is equal to 12.6 into 10 raised to 3 minus delta. So you can find out delta, and delta from using this equation you will get delta is equal to, the gap that has to be provided is 1.764 millimeter. Okay, you can either substitute these values, or you know this value directly because you have obtained it earlier. this is the free expansion, alpha into T into L, this is equal to 3.024 you have already obtained. So you'll get delta as 1.764 millimeter. Okay, thank you.